Here is a prize platform. First winner, the first prize, second prize, third prize. What is the surface area of a prize platform? Here I want to count the bottom in the surface area as well. Let's pretend that the platform for awarding the medals is made by cutting a 1 cubic meter block, 1 meter by 1 meter by 1 meter, into 3 slabs. A slab is something where I cut horizontally, of height 1/2, 1/3, and 1/6. What is the surface area of the platform that they make when they're all put together? We have seen these kinds of platforms many times, especially at the Olympics. What I'm looking for is the surface area, and the surface area includes the faces that look like this. And just to remind people, this has many different sides. So for example, the same prize platform, we need to count this area, and we also need to count this area. And for this problem, I also want to count the bottom and the tops. Okay, how do you do this kind of a question? The problem told me that it was 1/2, 1/6, and 1/3. If you look at this, at first it might look like there is a lot of different addition and subtraction to worry about. Because, for example, if I was going to do this by counting the area of that blue piece, I would have to take 1/2 minus 1/6, I would get 1/3. I could do it this way, and the answer will work. There's another way you can do this, which is to pretend that I just have these 3 blocks themselves separately, and then when they come together, to subtract twice the surface area that is made, which is removed when the 2 come together. That's another way. Also, it involves a lot of calculation. Something I want to tell you about this problem. In this problem, there are some numbers that are given so that you feel like you should maybe use them. But don't use numbers until the end when you know what you're about to do. So far, all these methods to me seem too complicated, too much work. Here's another way, which is a very nice way to do this. Actually, this is the way that I usually do surface area problems. I imagine a light shining from each of the sides. I have here something made from rectangular objects, so I can think of 6 directions that light is shining. For example, what if I have light shining from this side? It's going to shine on these parts, which are blue. In fact, let me go to the next picture where it's easier to draw all of this. Let's have these 2 with blue light shining. This one, I shouldn't use blue, because on this other side, maybe let's say that the light on the other side is a different shade, light blue. The reason I do this is because actually the amount of dark blue, these 2 things add up perfectly to the height of A. And the height of A, let's remember, was exactly 1/2. And so that blue here, remember that the width is 1. So this blue is giving me 1/2 as my surface area from that part. This light from here, this blue, is giving me another 1/2 from here. At this point, we already find out that the important fact was that the highest piece, A, was 1/2 tall. 1/2, 1/2. What other directions of light might I have? Well, there's light that comes from the front, from where you are right now looking. That light would cover all of this area. What's that? Let's look back at the block from which these were cut. That is exactly this. Oh, it adds up to 1. I don't even need to use the fact that this is 1/2, 1/6, 1/3. It was all from the slab, so that's 1. So this side is a 1. Actually, that means that the other side, because it's symmetric, is also a 1. And to finish this, let's just worry about the top and the bottom. Each of these was 1 by 1, so from the top down, I will pick up another 3 here, and from the bottom up, I will pick up another 3 there. So now I just need to add together all these numbers. 3 and 3 is 6, and these add up to 1, 1, 1. 6 plus 3 is 9. And so the answer to this entire question is actually just a very nice whole number, 9. And this question is an example of one where actually there's a lot more information than you actually need. all you need is just to know how tall is the tallest block. If this was 1/2, and this was pi divided by 4, and this was 1/2 minus pi divided by 4, the answer is still 9. And this is a lesson in that when you're doing a problem, even though it may look like it's possible to calculate all of the pieces out, think before calculating, because you might find a better way to do the problem. In the end, the goal of this type of question and of other questions in this AMC 8 inspired series is to try to think of creative ways to solve questions. Actually, that can make your life much better. Not only will it save you time, but you will learn some interesting insights that will make mathematics, geometry, combinatorics, probability, and algebra all make more sense.